Hey guys, we're going to start this lesson by reviewing a few skills that kind of lead us right into the lesson. So we'll start with finding inverse of a matrix. So in order to find the inverse of a matrix, first we find the determinant. Okay, so the determinant is found by multiplying the main diagonal, which is -8, and subtracting the product along the secondary diagonal, 1 times -7. Okay, so we've got the product of the main diagonal minus the product of the secondary diagonal, and -8 minus -7 is -1. Okay, now we're going to multiply the reciprocal of this determinant. Okay, so we're going to take the reciprocal. The reciprocal of -1 is 1 over -1, which happens to be -1. Okay, and we are going to multiply that by this matrix, but when I bring this matrix down, in order to find the inverse, I'm going to switch the elements of the main diagonal. Okay, so they trade places. And I'm going to negate the elements of the secondary diagonal, so they change signs. And then I will multiply by that scale factor, 4, -7, 1, -2, and this is the inverse of this original matrix. Okay, and we're going to use matrices to solve systems of equations, so let's talk about solving a system of equations. So it looks like the easiest way to solve this system of equations will be eliminating the z's. If I combine these two equations, they're already set up to eliminate z's, so I'll get 6x minus 3y, z's eliminate, equals 1. And if I multiply this one by 2, and then I'll just rewrite it up here, I can eliminate z's between these two equations. So I'll get 8x minus 18y minus 8z equals -6. Okay, so now when I combine these, I get 10x minus 15y equals -5. Okay, then I can multiply this equation by -5, and I'll write it right here, and I'll get -30x plus 15y equals -5. And when I combine these two equations, I get -20x equals -10. And when I divide by -20, I get x equals 1/2. Okay, so there's my value of x, 1/2. I'll plug that in right here. So I get 6 times 1/2 minus 3y equals 1. Half of 6 is 3, so 3 minus 3y is 1. I'll move that 3 to the other side. -3y equals -2. And -2 divided by -3 is 2/3. Okay, now I can plug x and y into any equation I want. I'm going to use the bottom equation. So I have 2 times 1/2 plus 6 times 2/3 plus 4z equals 4. 2 times 1/2 is 1. 6 times 2/3 is 4. Okay, so my like terms give me 5 plus 4z equals 4. Subtract 5, 4z equals -1. And divide by 4, z is -1/4. So my solution set is 1/2, 2/3, -1/4. Okay, and then we're going to solve this equation right here, and the easiest way to do this is to multiply by the reciprocal, which is 4/3. A reciprocal is also called a multiplicative inverse. Okay, so I'm multiplying both sides by 4/3, and I do this because when I multiply inverses by each other, I get 1. The 4's cancel, the 3's cancel, I get 1x equals negative times positive is going to be negative, and I can simplify this way. 21/3 is 7, and 7 times 4 is 28, so I get x equals negative 28.
First, you get an identity matrix. So if it was a 2 by 2 times its own inverse, you get this identity matrix. If it was a 3 by 3, you would get a 3 by 3 identity matrix. So if we think of this in terms of names of a matrix, you've got matrix A times matrix X equals matrix B, and you want to get matrix X by itself, then you could multiply both sides by the inverse of matrix A. Okay, now when you multiply these, you get the multiplicative identity, which would be an inverse matrix. Sorry, not an inverse matrix. You get an identity matrix. Okay, an identity matrix is the matrix version of regular number world's number 1. In other words, these cancel each other out. Okay, so you get that matrix X is equal to the inverse of matrix A times matrix B. So in this example here, if I want to solve this system of equations, I can do so using matrices. My x and y coefficients, 2 and negative 7, become the top row. And then 1 and negative 4 become the bottom row. And then my x and y are the second one, second matrix. And I use what they equal as a third matrix. Okay? If I want to solve this, then I can multiply both sides by the inverse of this first matrix. So we need to first find the inverse of that matrix. So to find the inverse, we start by finding the determinant. And that is the main diagonal product. So 2 times negative 4 minus the product of the secondary diagonal, 1 times negative 7. Okay, so we get a determinant of negative 1. Okay, so we multiply the reciprocal of negative 1, which is its own reciprocal. So we multiply negative 1 times, and we take this and we switch the main diagonal, and we do opposite signs on the secondary diagonal, and we get 4, negative 7, 1, negative 2. So that is the inverse. Okay? So if I multiply both sides here by that inverse, this side will cancel, and I'll get this. X, y equals the inverse, 4, negative 7, 1, negative 2, times negative 11, negative 7. So when we multiply, we do the first row by the first column. So we're going to get negative 44 plus 49, which is 5. And the second row by the first column, negative 11 plus 14, which is 3. So that means that x is 5 and y is 3. We'll try to clean that up a little bit. All right, so that may not seem any easier than the work we have done in the past, but as we turn to the next page, we're going to see how we can do that on a calculator. Okay? So here is exactly the same system of equations. So I'm going to turn that into matrices. Okay, so I'm going to just change this into different names, A, X, and B. So we've got matrix A times matrix X equals matrix B. So what I can do to get X by itself is multiply both sides by the inverse of matrix A, and that will cancel that out. That gives me an identity matrix, which is essentially 1 times X, which is just X. Okay? Now, I can go to my calculator and use matrices. So they've got different ways to get to matrices. This one you have to use second and then matrix. And I am going to go over to edit, and I'm on matrix A, so that's number 1. And I am going to put in matrix A here. So that is a 2 by 2 matrix. 2, -7, 1, -4. And then I'm going to go to matrices again and edit matrix B. And here's matrix B. It is a 2 by 1. Okay, I've got my 2 matrices in there. I'm going to quit. So second and quit. I'm back to my home screen. So I want to do matrix A inverse times matrix B. Okay, so I'll do second matrix. And now I'm just under the names column. I'm going to pull up matrix 1. So my calculator is telling me it's going to use matrix 1. And I want to do the inverse of that. So I use this little x -1 button to get A inverse times second matrix 2. So now I've got matrix A inverse times matrix B, and it tells me 5, 3, which means that my x is 5 and my y is 3. So we got exactly the same answers as we did in the previous problem. Okay? So that means as we go to number 6, I can go back to matrices, we'll edit matrix 1. This time I'm doing a 3 by 3 system, so I need a 3 by 3 matrix, and it's 2, 3, 8, then 4, -9, and -4, and 2, 6, 4. You have to be very careful because if you miss one sign or one number, this whole thing will get thrown off. Then I'm going to go back to matrix and go over to edit matrix 2, and this is going to be 3 rows by 1 column. 3 by 1. 1, -3, 4. And now I'm going to quit. Second, quit. So once again, I'm going to call up matrix A and multiply its inverse by matrix B. Okay, so I've got some decimals there, so I'm just going to go to math, option 1, enter, And there's my x, y, and z values. Okay, so this time, instead of writing it as x equals y equals z equals, I'm going to write it as a set of coordinates. 1/2, 2/3, -1/4. So those are my values of x, y, and z. All right, so this one is a 3x3 system. Notice there's an x and a y. Here's an x and a z, and a y and a z. Okay? So in this case, I don't have a z, so I need to make sure I use a 0z here. And that this one gets a 0y, and this one gets a 0x. Okay, so I still have to input it as a 3x3 system. Okay, so go to matrix, edit matrix 1 to a 3x3, and we have 12x, -5y, and 0z. And then 18x, 0y, and 9z. And then 0x, 30y, and 4z. Now I'll go back to matrix and edit matrix 2 to a 3x1, 8, -12, 0. And then I will multiply, so I'm going to hit second and quit. So I'll do matrix A inverse and multiply that. Oops. Try that again. Matrix A inverse times matrix B. Okay, once again I've got decimals. We'll just go math, enter, enter, and get that turned into fractions. So I get 5/6, 2/5, and -3 for my x, y, and z. All right, one more practice. So we'll go to matrix, edit matrix 1. This is a 3x3 system because I have x, y, and z. So I have 2 for x, -2 for y, and I don't have a z, so that's 0. Then I have all the x, y, and z for the next 3, so I've got a 3, -1, and -9. And then 4, 10, and 1. Okay, so I'll quit. So I'm going to go back into matrix and edit matrix 2 to a 3x1, -12, 15. Oh, I've got them. I'm doing the dimensions here. I don't want that. So let's clear those dimensions. 3x1. That didn't do it either. All right, so we're at 3x1, -12, 15, and 20. Okay, so second quit. Now I'll call up second matrix 1 inverse times second matrix 2. And I've got those decimals. Math, enter, enter to get a fraction. So I get -339 over 128, 429 over 128, and -187 over 64.